morning. Well, good afternoon. It's actually Friday, but I'm filming this for Monday. It's Mr. Treewin, and I'm ready to go over another lesson for geometry. Today's lesson is going to be a little bit of a recap of something from Algebra 1. And I'm going to go over, even though I think that we should have already covered this by now, I want to go over it again, how we're going to graph a line. So for our purposes today, graphing the lines is going to come in two flavors. We're going to have our first one, which is called slope-intercept. We like this the best because this is the one that's already ready to graph right out of the box. It says y equals mx plus b, and all I need to do is figure out what the slope is and what the intercept is, and I can draw my graph. The other way that we do this is called standard form. Not so user-friendly, because standard form is going to require us to do a little manipulation before we can get a nice graph that we can work with and draw a picture of very quickly. So I'm going to start off with just breaking down real quick on the first one, slope-intercept. It's called y equals mx plus b. And I've got a couple things here that I'm going to express that aren't the most mathematical ways of explaining things, but it is the best way to make it so you understand. When I talk about y equals mx plus b, the m stands for slope. And I know that's hard to understand why they use m as a variable when I'm talking about slope. And I'll tell you what I remember m as, moving. It's how much I'm going to move is what I think of. And then the b is called a y-intercept. And I like to think of that as the beginning spot, where I'm going to start this process at. So I'm going to start my examples. I've got 6 examples that I'm going to work out with you today. I'm going to graph. And my first example is y equals 2/3 x minus 4. All right, well, there's 2 numbers that are important to me in this process, and it's going to be the 2/3 and it's going to be the minus 4. So if I follow the model of M for movement, B for begin, and again, I know that's not the most mathematical thing, and you're not going to find a textbook that says it, but in all actuality, that's really what happens. The M stands for the moving, and the B stands for where I begin at. So in this case, y equals 2/3 x minus 4 means that I need to begin on minus 4. But there's 2 minus 4s on a graph, so that's where it really comes into the actual mathematical term. It's called the y-intercept because that's where this graph is going to begin. It's going to graph on the y-axis at -4. So let me check my pen here. Ready to go. And I'm going to go to -4. So I'm beginning at -4, which is my y-intercept, which is also where I crossed, if you notice, the y-axis. Now, the slope. Slope is called rise over run. It's a change in your position up and down versus the change in your position left and right. We call it rise over run. And in our case, our rise over run is 2/3. So I go back to my beginning location, and now I need to count up 1, 2, got to count up 1, 2, and then I need to run 1, 2, 3. So this is called my slope. And if I follow my slope, I can do this again, rise 2, 1, 2, 1, 2, 3, all the way across the page. And I kind of make this little staircase situation like this. But the graph of the line is right here. And the slope is kind of the rise run, and it builds this little staircase, if you will, across the page. All right, so that is the graph of our first one. Obviously, we don't really need all of this. We don't need my little staircase. I like to put it there just so it's easier to remember, but no, I don't really need the staircase. But it graphs me the line y equals 2/3 x subtract 4. All right, so we're going to do another one. This time I'll change it up and have a slope of a negative slope this time. We'll see how that changes things. And by the way, going back to slope, if you read this from the left to the right, like we should read all of our textbooks from the left to the right, as I read from the left to the right, I can see that as I go across the page, you can see my hand is going up the page. That's because the slope was positive. I should be increasing as I go across the page. All right, well, let's try our second one. Y equals -4/5 x plus 1. Well, our slope is -4/5. So that means that instead of going up the page, we're going to be going down the page as we read across. So our slope is rise -4, run 5. And our intercept is 1. So remember, our intercept always goes on the y-intercept, or y-axis, because it's called the y-intercept. Again, I like to think of it as my beginning point, and so if I go to draw a picture, I know that I need to start at the number 1. Okay, and then what I need to do is I go back to that beginning point and I count out my slope. And this time I'm going downstairs. I'm going down the page. So I'm going to go like this. Starting here, I'm going to go down 1, down 2, down 3, down 4. And now I need to go over. 1, 2, 3, 4, 5. Okay, and if I wanted to, just in case I ever need to, now you can see my little staircase is right here. I can do that again. I could go back over here if I want to draw a better line. But if I go on this side of the page, instead of going down 4 over 5, I'm going to go back 5, 1, 2, 3, 4, 5, up 4. And you can see I made the same staircase. And that tells me exactly where to draw my line, because I just connect the dots with a ruler and I get my equation. And again, I can subtract this part. I don't really need all that. But again, if you're trying to draw a graph, it's really helpful if you just maybe draw the stairs all the way across the page. Okay. Well, moving on, we're going to do one a little bit different. And it's oddly enough, the next two lines are most confusing to students. And I think it comes down to the lack of information that you get a little confused. And it's probably because they don't really fit that perfect mold. When you see y = 3, it doesn't really fit with this, and it doesn't really fit down here. And these are straight lines. They do not go diagonally across the page. They don't have a rise and run, and they're going to go straight across the page or straight up and down the page. And so when our line is called a y = line, we call that a horizontal line, because it's going to go directly across the page, straight across the page. And because it has no mx portion, it has no y = mx part, it just has a y and a b. What happens is, and the way I like to read this is a horizontal line, and what it tells me is cross the y-axis at 3. Just cross the y-axis. Well, this is the x-axis, and this is the y-axis. And what I need to do is I just need to cross the y-axis at the number 3. And it looks like this. And I cross at 3. And that's called a horizontal line. So if it helps you, we'll just write it down, horizontal. And it goes across the page. I'm going to leave that one up because when we do its counterpart, the vertical line, that one's going to go up and down the page. And we read it very similar as we read the other one, in that we say, all right, x = -2. Well, that means you're going to cross the x-axis at -2. I'm going to change my pen color here so we have something different to look at. So cross the x-axis this time at -2. So that would be right here. And this is called a vertical line. I like to think of this one as, if you think about it in your house, you got vertical blinds, are the ones that go up and down, and then they have horizontal blinds that go across the page. But the way we look at each of these is that they're only going to go in one direction, straight up and down the page. And that kind of comes from the fact that they only have one variable. If you think about it, in a problem like this one here, y = 2/3 x take away 4, it has a y value and an x value, which means it has to cross the x-axis and the y-axis. Same with the second one. If you think back to the picture, it crossed both the y-axis and the x-axis, and it had two variables. However, when I get to this one, I only have one variable, which means it's only going to cross one axis. In this case, it's the y-axis. On the fourth example, it only had one variable, and that was the x, meaning only cross the x-axis. All right, so for our last two examples, you can see they both have x and y, which means they're going to cross both axes. And on this one, it's going to be a little bit more work because we're going to have to, what we're going to have to do here is we're going to need to get them in a format that we can graph. And the way they're written right now is not the most user-friendly. So I'm going to bring my pen over here, I'm going to set up, and I'm going to show you how we're going to convert this one from standard form to slope-intercept. So I'm going to start by writing down the equation. And what I'm looking to do here is I'm going to try to transform this from standard into y-intercept, or slope-intercept. So I need to get the y, basically. What I'm looking to do is get that y variable all by itself. So I need to do a little bit of adding and subtracting and then a little bit of division to get my answer to say y equals. So doing that, I can see that it says 3x minus 2y, and I'm trying to get here. So I'm going to start this process by subtracting the 3x. And I'm going to move that to the other side. I'm going to rewrite it. And remember, the format is y equals mx plus b. I want to get it in that format. So what I want to do when I rewrite it, I want to put the x's first. So I see that mx. So I'm going to go ahead and rewrite it like this with negative 3x. And then I see that that's just a 6. It's just a plain 6, which means it's a positive 6. And so you can already see this starting to take the form of y equals mx plus b. Now, I still need to get the y by itself, so I'm going to need to divide by negative 2. So if I take and I divide everybody by negative 2, I'll have converted this completely into slope-intercept. So the negative 2 over the negative 2, that's going to go ahead and cancel. I'm going to write another one. I'm going to write that right here, y equals. Now, I have a negative 3 divided by a negative 2. Well, a negative divided by a negative is a positive. So I know that my answer has a positive slope. And then if I think about it, 3 doesn't really divide by 2. It's in simplest form. So I'm going to leave it. I'm going to leave 3 over 2. Because remember, I need a slope anyways, which means I need to be able to count in the up and down position, and then I need to count across the page. If I make that into a decimal, how am I going to count a decimal? It's not going to work. And then the last part, positive 6 divided by negative 2. Well, that's going to be negative 3. Well, I got all my information now. I know exactly where I need to start at negative 3. I know exactly how much to make my little staircase, my rise over run. So I should be good to go here. So let's go ahead and draw the picture. I'm going to change my markers to another color here. And I'm supposed to start at negative 3. I don't know what's going on with that. Whatever. So I start at negative 3, and then my slope tells me that I need to rise 3 and run 2. So my staircase, if you will, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So this gives me, I just connect my dots, and this gives me the graph of that function right there, or that equation. 3x minus 2y is equal to 6. And again, what I did was I converted it from standard form to slope-intercept, and then I was able to draw the graph out. So we're going to do one more to wrap this video up. I want to keep this at a relatively short video, so I know I'm doing a lot of recapping of things that you might have already learned in algebra, but hey, it was a weird year last year. I want to make sure I go over everything. When you have summer that lasts 5 months long due to COVID, hey, gotta going over some things a few times. All right, so our last one, x plus y equals negative 3. So I've got x, oh, no I don't, I gotta draw, x plus y equals negative 3. Okay, so I need to get x from the left side, I need to move it over to the right side so that I get y by itself. So I can see maybe subtract the x, And now let's bring down what we have. We have y equals negative x minus 3. All right, well that always confuses people because you guys are looking for a number to graph and I'm not providing much help here. I'm not giving you a lot of numbers to work with. I gave you that negative 3 and you know that's the starting point, but then I just gave you negative x and I know that right now it's confusing and that's okay. If we're talking about rise over run and I don't see a number, maybe it wouldn't be the worst thing if maybe we rewrote it, and I'll do this all day long as a teacher. I will rewrite because I know that in front of that x is supposed to be a rise and a run. So I know that in front of that x is really a 1. And I also know that it wouldn't be the worst thing in the world if I wrote underneath it, since I know that I got to do a rise over run, would it be okay if I just put a 1 there? I don't think it hurts because it helps me visually see how much I need to go up or down. So a lot of people say that that's kind of a middle school type of thing, but you know what? If that's your opinion, that's your opinion. It's America. Get over it. This is the way I like to do it. It keeps it so people know what they're doing. All right, so anyways, I go over here and I look at it. Now I have a slope I can work with, and I know this is right because -1 over +1 is really -1. I just needed that visual thing. So anyways, I go over here and I say, all right, I'm going to start at -3 on my y-axis because it's the y-intercept. And my slope says go down 1, over 1, down 1, over 1. And remember, if I want to throw this in reverse and go up the page, I go back 1, up 1, back 1, up 1. And I can just go all the way across the page. And that is how I would explain graphing. And so I've given you 6 examples. Hopefully this will do it for you as you work through each problem. Remember though, key things. Slope is a ratio. It's always going to be a fraction. If the number in front of x that you see does not have a fraction, maybe it just has a whole number, it wouldn't be wrong in any way for you simply to draw a little fraction sign and throw a 1 in there. And that way you'll remember that this is a rise over run situation and you know that how you're going to graph. All right, I hope this works out. I hope we do well and have a good day. Bye.